All right, today we're going to be talking about rationalizing the denominator. This is a skill that you would need if you're going into geometry, and it's something that's done pretty often, pretty early on. So just want to brush over kind of how this works. So the idea is that when we have a square root in the denominator, it is not in its most simple or final form, and we have to get rid of the square root in the denominator. So the way that we do that, we call that rationalizing the denominator. We're allowed to change a fraction. So I'm going to take a moment here, and I'm going to use 1/2. Okay, so we can change a fraction by whatever we want as long as we multiply by the same thing on the top and the bottom. So think about if I multiplied by 2 and 2 here. That's going to give me 2 over 4, which is still 1/2. To take this even further, essentially, think about what 2 over 2 is. If I multiplied 1/2 by 2 over 2, 2 over 2 is really just 1. So track with me here. Anything that I multiply times 1 ends up being the same thing. $10,476 times 1. Guess what? It's the same thing, 10,476. I can multiply anything by 1 and get the same thing. That's the identity property. When we're changing fractions, if we multiply by the same number on the top as we do on the bottom, that's the same thing as multiplying by 1. So even though we've changed the fraction from 1/2 to 2/4, it still means the same thing. It's just kind of like a different version of the same value. It's still the same value. So all that to say, when we are rationalizing the denominator, we're keeping the value of the fraction. We're just kind of changing its form. So what we're going to do is we're going to multiply by the same value that's in the denominator. So, or rather the same number in the radical. So by radical 5. Now remember, if I multiply the same thing to the top and the bottom, I'm really just changing it by 1. I'm just changing its factor. So 5 times 5, we multiply whatever is inside the square root together, and we multiply whatever is outside. So in this case, we only have 1s on the outside. They're not seen. This is a 1 radical, or 1 square root 5, and a 1 square root 5. We don't have to worry about the 1s. So 5 times 5 is 25. So that makes square root 25. And we can take the square root of 25. We get 5. And then we just do the top. 11 times square root 5. Well, 11 times the outside here is 1, so 11. And square root 5 doesn't have anything to multiply with, so it stays as square root 5. And then our last thing we would check, sorry I jumped and just boxed it, we would check to make sure we can't reduce our outside numbers. So I'm just going to take you through a few of these. Some of these had cube roots, and we're not really dealing with that. So check this out. We have 7 over 2 square root 2. I'm going to multiply square root 2 to the top and the bottom. Okay, so now this becomes, I'll use blue, this makes 2 square root 4, because I did this 2, didn't really change, and then 2 times 2, square root 2 times square root 2, square root 4. We'll deal with that a little bit. We'll simplify that in just a moment. And then we also get up top, we get just 7 square root 2. And now we're going to deal with this 2 square root 4 thing. The square root of 4 is 2. So if I take the square root of 4, I get 2. So what this really is saying is 2 times 2, which is 4. So we got 7 rad 2 over 4. And then we check, can 7 and 4 reduce? And they cannot. We can't reduce this 4 and 2 because this rad 2 is, because it's in the radical, it can't play with the 4. Only the outside numbers can play outside together. I know this is probably seems pretty confusing, but I just want you to be exposed to this, not necessarily even understand it fully, because it would come with practice. So we're going to look here. We have to multiply the top and the bottom by square root 3. Okay. My next step, which I'll write in blue, everything on the outside multiplies together, so that 3 on the outside didn't have anyone else. And then on the insides, those multiply up to make 9. So this says 3 times the square root of 9. Remember, though, the square root of 9 is 3, so it really is 3 times 3. So I'm going to get a 9 in my denominator. Okay, and then up top, square root 2 times square root 3. They're both inside the square root, so we can multiply them up to make square root 6. And then this doesn't have anything that reduces or breaks down or anything like that. So we just leave it as square root 6. We cannot reduce these because this is inside, this is outside. They can't play together. One's playing inside, one's playing outside. Okay, last couple. Just want you to see it, familiarize yourself with it. You may or may not be using it next year, depending on in what class you're going into. So I'm multiplying by rad 13, or square root 13. On the bottoms, now if you noticed a pattern, every time we multiplied by the square root in the bottom, it made a perfect square that then just turned into the number we had inside the radical without it. So again, rad 3 times rad 3 ended up turning into a regular 3. And that's kind of the shortcut here I'm going to show you. When we multiply a square root 13 times a square root 13, it really just makes a regular 13. You could multiply 13 times 13 and get 169 and then divide and then take the square root of that. Or kind of the shortcut is if you have 2 square roots that are multiplying that are the same, your answer is just the number that's on the inside. And then 4 times square root 13 is 4 square root 13. Okay, this will be the last one. Same idea. We take square root 15 and we're going to multiply it to the top and bottom. So again, we're not really changing the value, we're just changing how it's written. The same way that if you have one $20 bill or 4 $5 bills, it's still, the value is still 20, but they're 2 different kind of versions. So the shortcut, square root 15 times square root 15 just makes a regular 15. And then we have 9 times square root 15, which gives us 9 square root 15. And then we're looking here at 9 and 15. Can they be reduced? And they can. 3 can go into 9 3 times, and it can go into 15 5 times. So our final answer here is 3 square root 15 over 5.